systems of equations, linear equations, looking at some application problems for homework number 1. These are the notes for number 14. If we take a look at this here, number 14, it tells you there's an admission fee of $2.50 for children, $7 for adults. The total of 1,400 people attended, and the total fees, as much money that they took in, was $5,822, and they want to know how many children and how many adults. The first thing you have to do is what's called initialize your variables. This is not an optional part of the problem. You have to know what your variables stand for. This is algebra. We're going to use variables to solve this. And you can use whatever you want. I just chose here X for the number of children and Y for the number of adults. If it makes it easier for you, you could use C for children and A for adults, but I just wanted to keep this real algebraic. We're used to working with X's and Y. So X is the number of children, Y is the number of adults. Not optional. That has to be part of your problem. That would be written with your work, is initializing what your variables stand for. Well, the next thing we're going to do is get our equation. Let's get an equation here. The number of total people is 1,400, so X plus Y is 1,400. Well, then the number of money taken in, well, it's $2.50 times the number of children. That would be how much you would take in from the children there, $2.50 times the number of children, plus $7 for every adult. So $7 times the number of adults. And they told us that that number was 5,822. That's the hardest part, I think, is just getting this set up, getting all the information, all those words, and getting it to algebra equation. Now we know how to do this. This is a systems of equations. And the notes multiplied this by 7. I probably would have multiplied this by -7 just so I could have added this, but I just want to follow, exactly what your notes have so you can follow it here. But if we just multiply this top equation by 7, you see that we can subtract and we can eliminate the y's. So let's see if I multiply that by 7. I distribute 7x plus 7y is this. Well, now I'm going to have to subtract because my signs are the same here. So if I subtract, and once again, I overemphasize it there that now I am subtracting, so I don't forget there. And so you can see what I'm doing. So 7 minus 2.5, 4.5x. Subtract here, then divide. X is 884. Well, then I go back into my original. I know X plus Y is 1,400. So if X is 884, then Y is going to be 516. And then your final thing is to answer the question that they ask. They asked how many children and how many adults. So there's 884 children, 516 adults. And that would be your answer, answering the question, labeled exactly what they asked. Well, let's take a look at one more problem. Let's take a look at number 15 on the notes. And they tell us, here's the information that they give us for this problem. They say we're gonna be flying here from Philadelphia to Pittsburgh. It's going to take us 2 hours, 260 miles. We're going to go into a headwind. We're going to go against the wind. Then we're going to return trip, Pittsburgh to Philadelphia. This is only going to take 1 hour and 15 minutes, same miles, 260 miles. But this time it's going to be a lot faster because we're going with a tailwind. And what those mean, a headwind is you're going against the wind. It's your actual speed, the speed that the plane can go. The plane is going to go minus the wind speed. So it's going to be slowing it down. The tailwind is going with the wind. It's the actual plane speed plus the wind speed. And if we let x be the plane speed or the actual speed, and then y is going to be the wind speed or the current or the wind speed. And let's see, I'm going to go ahead and make a chart here. If I make a chart here with distance, rate, and time. So with a headwind, there we have still the distance. Distance is going to be the same for headwind and tailwind. For a headwind, going into the headwind, your rate is going to be x minus y, the plane speed minus the wind speed, and our time is 2 hours. Tailwind, the rate is going to be x plus y. It's going to be the plane speed plus the wind speed. And our time is going to be 1 hour, 1.25 hours. We want to get just to 1 unit. We can't have hours and minutes. So that would be 1 and 15/60 hours. So just 1.25, 1 and 1/4 hours. And remember the formula here, distance equals rate times time. I usually refer to that as the DIRT formula. Distance is rate times time. So if we set that up here, if we have, well, if I take the time times the rate, so 2 times the rate is x minus y equals the distance. And then here I have the time, 1.25 times x plus y equals 260. Well, you could distribute this out and then solve this equation by either substitution or elimination. I just find it so much easier in this problem to just rewrite these, divide both sides of this equation by 2, so you get x minus y equals 130. Divide this equation by 1.25, so you end up with x plus y equals 260 divided by 1.25 is 208. This makes such an easier problem. And this is really set up now for elimination. It just is so much easier to do elimination. All we have to do is add these together and we eliminate the y. We just add those together to eliminate the y. So we get 2x equals 338. So x is 169. And then go back and plug this anywhere in above that has an x and a y in it and find out that y equals 39. So then we have to answer the question that they ask. The plane speed, the actual speed, would be 169 miles per hour for the plane speed, but then the wind speed is 39 miles per hour. Hope that helps.